All potential questions. Jeremy Schwartz. 12. Ladies and gentlemen, problem number 12. Let's take a quick look at problem number 12. If you can solve any equation, you should be able to solve number 12. Okay, let's just look at this. I am going to change this so that it looks like a normal thing. If you have 2x plus 8 equals, I don't know, 14, Jeremy. Really the same equation as this, except there's numbers instead of the letters. The process is exactly the same. In other words, if this was the equation, what would you do first? Subtract the 8. So I subtract the 8 from 14. And then the only difference in this one is when I subtract my b, since these are not like terms, you can't really do the subtraction. You have to leave it as c minus b equals ax. Over here I can because they were numbers and it just ends up being a 6. So now I'm left with 2x equals 6, just like I have ax equals that. How do I get x by itself here? Divide by the 2. Well, that's what I got to do here, except it's not a 2, it's an a. And then you just do that. C minus b over a is your answer. You can't simplify it any more than that. And I would prefer, if, by the way, Jack, if you had this written like this, you would be wrong. If you're going to do it like that, this would have to be in parentheses because the whole thing gets divided by a. If you wrote it like that, that means just the b gets divided by a. And that would not be right. That's why I strongly, Jack, recommend just writing it like this. And then everybody's happy, including me, which is probably the most important person that you want to make happy at this point. John?
Number 2.
Number 2. Number 2. Yeah, Alex figured she saved $12 by drawing an item at 30% discount. How much did she pay for the item? Again, best way to do this is just to draw the box. Best way. I used to back in the day go over a long, complicated thing. There's nothing easier than this. Here's your percents, here's your real numbers. It was a discount, so you've got, anytime it's a discount, you have the original number minus the discount equals what price you paid. Equals the final price. So you just need to fill in the box. It was a 30% discount, so that goes here, and then you can fill in all your percentages, because original is always 100%, minus 30% gives you 70%. What do we know? $12. She saved $12. So is that the original price? Is that how much the discount was, or is that the final price? That's how much the discount was. And they want to know how much did she pay, the final price for the item. Don't even need the top. 30 over 70 equals 12 over what number? And this one works out nicely because you can reduce this by tens. 3 times 4 is 12. 7 times 4 is 28. $28 was the final price. No easier way. I used to go through a whole long equation. It was just brutal. I can't even believe I did it back in the day. Lauren.
Okay, how do you do number 4?
4.
Because I got a 747.
Oh, you know what? Oh, 4. I thought she got 3.
No.
4, 3 we're just going to ignore and hope it goes away. Number 4, children. This was the one where you have to draw the 2 different examples. Okay? You have to draw something, increase it by 50%, and then do the whole fraction box. No easy way about this. Not an easy problem. That's why I'm not even going to make you do number 3. We'll just make you do number 4. So you just start by this. You got to draw. And again, they don't give you the dimensions, and the beauty of that is you get to pick whatever one you want for the screen. Make it easy numbers to work with. Something that's easy because you're going to increase that number by 50%. So your call as to what it is. Might I suggest a 10 by 10 because 110s are easy numbers to work with? So just in case, just for whatever. So now I've got a 10 by 10 screen. I now increase that by 50%, which means, what is 50% of 10? What's half a 10?
5.
But that's how much I increased it by. So now my screen is 15 by 15. Okay. Now my new screen. Now I'm talking about the area, so I need to find the area of these. Well, 10 by 10, that's 100 for the area. 15 by 15, anybody? 225. Now you know their areas. Now, again, best thing is just to draw a little box. And here's your box. It is an increase, which means you have an original one, which is what you started with, plus the increase equals the final. And this is percents and this is actual. The original percent, or the original area was 100. The final area was 225, so that means it went up 125. The original area was 100. Ooh, look, that's going to be nice. We don't, well, this is not, see, this 50% is not the same as this 50%. Okay, this 50% was by how much bigger the sides got bigger. We don't know how much the area is, so that's the question mark. We don't know, and we don't know that. So you have to say its area increases by what percent, so this is what you're looking for. 100 over what number equals 100 over 125. Well, that's going to be tough. What's it going to be? It's the same fraction. 100 times 1, 125 by 1. So it increased by 125%. Now, if it would have asked you what percent the final was of the first one, it would be 225. And again, the reason it worked out like that was because you picked 10 and 10 as your first things. It wouldn't have been that easy if I had picked 2 or 8. You could have still done it, it would have still worked out, but you'd have done a little bit more calculating over here. That's why let me suggest if they give you something like that, make your first one. And it didn't have to be 10 by 10. You could have made this 10 by 4. It just said it was a rectangle. Well, a square is a rectangle, so you can use a square, but you are your own boss, so pick whatever's easiest for you. And I suggest 10 by 10. This public announcement was made possible by squares everywhere. Brandon Norman. Number 7. Formula for this sequence is a sub n equals n squared minus 2. Writing this down right here, Brandon Norman, the only thing you need to know is what does the letter n equal? What does n mean? What is n? Anytime we talk about sequences, the letter n is the number of the term you want. So as you read this problem, a formula for the sequence, what is the 12th term of the sequence? What term do I want? I want the 12th term. That's what the letter n is. I put in the number 12 for the letter n. Okay? So this first part is a to the 12th. That just means you're talking about the 12th term. You want to know what that equals. Well, it equals 12 squared minus 2. What's 12 squared? 144. Subtract 2 from that, you get 142. You don't need to worry about this, because that's just the variable you're solving for. You just plug that in there. Everybody's happy. I love 7th grade math. I'm thinking next year about kind of bumping Algebra 1 until we actually, I'd rather go through the rest of this book than start Algebra 1. Because I think you learn more with this than you do with the Algebra book. Because algebra gets into this really hard, complicated stuff that, we'll get into some of that. Your scores are better. As a matter of fact, you guys will probably score higher in the math test using this book than you will as 8th graders. Because you forget some of this stuff. Because they get really technical. Lit.
For number 4, I just when I drew the box, I just made each side 2, and then when I finished that, I crossed it off and made it 3 by increasing it by 50%. Because when I do by 100, it would be like.
So you did 2 and 2, and then 3 and 3.
Yeah, and
That
then
works.
just dividing 50 by 4 and taking out every 0.
So what are you telling me? Did you get the right answer?
Yeah.
I said you could use whatever you want. I don't care. I'm just saying this, to me, because you're using hundreds, it just works out very quickly there. Nick? Is there a groan of approval on number one?
Yeah.
Is that what you were going for, Callum?
Yep.
Good. A deck of 26 alphabet cards contains one card for every letter, including the vowels A, E, I, O, U. Or in Spanish, it's what? I, E, A, O, U. Here is the important thing, people. A card is drawn and not replaced. Those are two important words when you figure out probability. Okay? You are looking for the probability of picking a vowel and then picking another vowel in that order. And it's really a pretty simple thing to do. Okay? It's to find that probability, you just multiply these probabilities together. Well, the probability of picking the first vowel, how many vowels are there? A, E, I, O, U. There are 5 out of how many cards? 26. Now here's the issue. You have already pulled one vowel out. You don't put it back in there, so your probability changes for the second one. There's no longer 5 vowels stuck in a thing. If I drew an A, I've only got the E, I, O, U in there. There's only 4 vowels left, and there's only 25 cards to pick from. So those two things change. If it would have said that they put the card back, it would still be the same. But they kept it out. They didn't put it back in, so there's no longer that same number. You just multiply this out, but I suggest that you cross-cancel beforehand and make your life just a touch easier. 5 goes into 5 once, into 25 5 times. 2 goes into this, 2 goes into that. 1 times 2 is 2, and 13 times 5 is 65. That's your probability. 2 out of 65 times would you pull 2 vowels out of an alphabet. Again, if tomorrow it says that the card is replaced, this would be 526, just like the first one, because your probability would be the same. Whew. Nikki.
I also don't get number 15.
Oh, sure. 15 is the downfall of many a math student. Tell me what you tried, Nikki Kala, and I'll tell you possibly the errors of your way.
Well, first I subtracted 0.5. Well, no, I multiplied them both by 10.
Okay, I'm game with that. So you'd have to first of all, you can't multiply just both of them. You have to multiply everything by 10. If you're going to multiply by 10, it has to be by 10, by 10, by 10. If that's what you want to do. You can't just pick 2 of the 3.
Oh.
Okay? And here's the example for that, Nikki. If I have 2 plus 3 equals 5, in order for that to stay a true equation and be multiplied by 10, 2 times 10 is 20, 3 times 10 is 30, and if I stop there, does 20 plus 30 equal 5? No, you have to multiply this by 10 as well to get 50. Now it's true. So if you're going to do that, this would have to be 10x minus 5x equals 12. And that's probably where you went wrong. 10 minus 5 is 5x. 5x equals 12. Divide by 5. Divide by 5. If you left it as a fraction, let me remind you, if they give the equation in decimal form, they'll put their answer in decimal form. So you'd end up with 2.4 instead of 12 over 5. If you had the fraction, you probably would talk me into giving it to you. Brandon Norman. I hope so. Emma Kreis.
I don't get how you said that you add 0.5.
How I do it. See, in this case, this is different than most equations, Emma Kreis, because these are like terms. You can put these together. This is an x and that's an x. So 10 minus 5 is 5. You have 10 x's, you take 5 x's away, you get 5 x's.
Where's the 10?
That was because Nikki Kala said she wanted to do it this way. There's a 1x there, and I multiply every term by 10 to get rid of the decimals. 1x times 10 is 10 x's, 0.5 times 10 is 5x, and 1.2 times 10 is 12. If that confuses you, you just do it decimal-wise and do it like this. What is 1x minus 0.5x? Well, it's $1 minus 50 cents. 1 minus a half is 0.5x. 0.5x equals 1.2. You're still going to get the same thing if you divide by 0.5. You'll still end up with 2.4. Either way you do it. Lucas Espanol.
I'm getting 245 for number
Wait, did we already do number 1?
1.
Why? How do you get that? Can I ask? I mean, what are you multiplying together to get that?
5 over 26 times 4 over 25.
And you cross canceled and got that? Or you just multiply 20 times 5 times 4 and then 26 times 25?
Multiply 5 times 4 over 26 times 25.
Okay, I don't know why you'd want to do it that way, but let's do it. Why not cross cancel? If you have 26 quarters, how much money do you have? I always love that one. What'd you get when you multiply 26 times 25?
450.
Is that true? $26, $4, and no, I believe you multiplied wrong. How about 26 times 25? 30, 13, 0, 52, 0, 5. I get $6.50, $6.50. No, am I wrong there? But again, Lucas, I don't know, why not just cross cancel here and not worry about all the big multiplication and stuff? 5 goes into 5, 1 through 25 5 times, cut those in half. Jackson?
I don't understand number 6.
It's not about understanding, it's about writing the formula down.
There we go.
You did write it down? What is the formula for the area of a trapezoid?
So that area equals 1/2 base 1 plus base 2 times 7.
Perfect. Then you must understand that the bases are the two parallel lines, and again, only of the trapezoid. It's not the whole line, it's only the trapezoid, so it is just this and this, because we're only talking about the trapezoid. You ignore the rest of these lines. So what is, Jackson, what'd you get for the EF? How long is EF?
Well, that's what I got wrong.
Well, this plus this plus this has to equal 20. So 5 plus 9 plus what number equals 20? 5 plus 9 is 14,
6.
so this has to be 6.
Oh.
So here, down here, you put 20 plus 6, and I believe the height was 12. And that's what the area equals. So it's 1/2 of 26 times 12. Half of 12 is 6, and 26 times 6 is 156, whatever it was. Inches squared, centimeters squared, units squared, something squared, somewhere up there. Emma Haynes.
For that problem, why would the plus be scaled to 6?
Why would the root of b squared? Why would the plus b squared be 6?
Yeah.
What did you get?
Well, is that just the top, or I didn't know.
In the trapezoid, the two bases are the two parallel lines. So here's my trapezoid. The two bases are the 20 and this top little piece right here, which is 6. Because 5 plus 6 plus 9 gives me the 20. You have to calculate that part right there. And it's not b squared, it's b sub 2. You don't square those. That is just a way to distinguish between this base and this base. B1, b sub 1, b sub 2. Those little number 1s and 2s don't do anything as far as mathematical stuff goes. They're just a different way to say two different bases. They're just a different label. Did that help you? Did you get your 6 and did you get your 20? You sure? All right. Emma Eugene Price.
Number 10, what was the formula for lateral surface area?
Oh yeah, let's write those down. Make sure you have these, people. Number 9, let's write that first of all. Volume of a cylinder is pi times radius times radius, this is the area of a circle, and you're multiplying that times the height. Area of the base times the height, that's the volume of a cylinder. The lateral surface area of a cylinder, LSA, is the circumference of the circle, which is pi times diameter times its height. The lateral surface area is the label of the can. And this will tell you the area of the label. It's its perimeter, its circumference, times how tall it is. So you need to put that down on paper, so tomorrow when you walk into the test, you just need to fill in the blanks, and that should be 2 of the easiest problems in history. Sage?
Yeah, I kind of don't get number 5. I get the EF part, but I don't get the other one.
E.F. Hutton?
What?
When E.F. Hutton talks, people listen. Well, Sage, let me just ask you this question. You said you got the EF and you can't figure out the CE and the FB, correct?
Yeah.
Well, let's take a look. I'm going to highlight this here thing here. What kind of a shape is this?
Triangle.
And what kind of triangle? What
uh,
special triangle is that?
Right triangle.
And what should right triangles shoot off in your memory banks right off the bat? The Pythagorean theorem. And that should make you think Pythagorean triples. So these are my 2 legs. Is there a 5, 12, something triangle? 5, 12, 13. And this one over here is the same thing, except, oh no, there is no 9, 12. And when there's no 9, 12, the next thing you look at is this a multiple of some smaller thing? Is there a number that goes in the 9 and 12? Yeah, so if you divide them both by 3, you get a 3, 4. And there is a 3, 4, 5 triangle, but the answer is not 5 because you divide it by 3, you have to then re-multiply by 3 to get the length of that long one, which is 15. Oh my. Lauren?
For number 13, if it was 3 plus x is less than 4,
I'm seeing that on the here. Is it on this side or is it over on the other side? Down here.
it was on the, like if it was that thin, would you end up switching the sign? Because
Let's talk about this one, because please jot this down in your notes, because I see the problem already. Your x is negative, and that can never happen in the end. We gotta fix that problem. And when you do that, things are gonna change. But the first thing you wanna do is get this x by itself. Okay, what do I do with the 3? Do I subtract it or do I add it? You subtract it, because it's what's in front of it? Nothing. And when there's nothing in front, it's a plus. So you subtract 3. You subtract 3. So now you're left with a negative x is less than 1. Okay? And unfortunately that's not acceptable because the variable can never be negative. But it's an easy fix. You just need to change everything to its opposite. Opposite for this, opposite for this, opposite for that. Now, I don't know if that was really your question, Lauren. What was your question?
yeah, like if it was 3 plus x,
If it was 3 plus x, then
Then
this
you
you
want
would have
to
not
have
had to
x.
change anything, because the x needs to be positive.
okay. Would be probably
And then graphing it, set the graph here at -1. It's an open circle because there's no equal sign there. Shoots off on the greater than side, which is this side. And make sure you draw all that stuff. That's the bare minimum I need is this. The open circle, the colored in darker arrow going to the side with the arrow on it going that way. That's bare minimum. Sometimes people just draw circles and arrows in the way. Brandon?
Can you do number 17?
Number 17. I was hoping I would get number 17. Oh. Again, a couple different ways to do 17. Who wants to throw the way that they do it? Because I'm not so sure my mind works as most seventh grade minds. Emma Haynes, what would you do first?
I took the 2y and the negative 1y, and I would add the negative 1 since it's positive 5.
Okay, so Emma Haynes is saying she doesn't like, and we don't in math like this negative 1y, so you're gonna move it to the bottom where it becomes a positive y to the first power, and then she puts them together, and that ends up being a y cubed. Did I get that right? Then what, Emma Haynes? So the y's are taken care of, by the way, they're gone.
How come it turns into a y cube?
Because you have 2y's plus another y is 3y's, y cubed. Actually, it's times. 2y's times another y. Y squared times y to the first is y cubed. Then Emma Haynes?
Or I would take the x and cross it off, and then cross off the
Okay, then Emma Haynes says, okay, I got one x up here, I'm gonna cross off with one of the 4 x's on the bottom, so I'm still left with an x cubed on the bottom.
and then I take the x2 and cross it off.
Okay, you got 2 x's up here you're gonna cross off, and they're gonna cross off with 2 of the 3 down here, so you're left with just 1 x on the bottom. And then what am I left with, Emma Haynes?
The 4, 6, 8.
Yeah, 4, 6 can be reduced, divide them both in half, the 2 stays on top and the 3 goes to the bottom. And again, there are a number of different ways that you can still do that and still get the right answer. I don't know which one is easiest or best for you particularly, but I mean, that's just the way it works. You know, you could bring them all to the top and then put them all together and then figure it out after that, or write all the letters individually, numbers. Lucas?
How do you do number 18?
I love number 18. I don't know why so many people get mixed up there. First of all, that is all addition, is it not? There's no multiplication there. Okay? And in order to be able to add terms, they have to be what we call like terms. They need to be alike. Like terms have to have the same exponents, or have to have the same bases with the same exponents. In other words, they're very, 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 I want to say racist, they're very discriminatory, they only like themselves. These x squareds only like other x squareds. That's the only people they'll go with. So here you have 3 of them, but here you're taking 1 x squared away. So if you have 3 x squareds and take 1 x squared away, you're just left with 2 x squareds. They don't change to x cubes or x to the 4ths. Okay? They're still x squareds. They like being x squareds. They don't want to change. Same thing here. These x's only like other x's. You have 2 x's, but then you take 1 of those x's away, that leaves you with just an x. And we don't usually put a 1 in front of it just because 1x is the same as an x. Okay, you can't put an x squared with an x. You can multiply these together and get 6x to the 3rd, but we're not. We're adding, subtracting, subtracting. Hence the reason why this ends up looking just like this. Problem 19, anybody want there? Sage, yes? Let's look at 19 because it's relatively quick. First of all, 2 separate parts because of that subtraction sign. Sage, there's nothing here to cross off. The negative 2 is just a negative 2. But this one over here is a negative, and then you have a negative 2 times a negative 2. That's what this square does. So, Sage, how many negatives do I see there?
2.
How many?
3.
And if you have 3 negatives, your answer is going to be now
Negative.
multiplying. And 2 times 2 is 4. Now, I'm adding, I have a negative 2 and a negative 4. Putting them together, I get a negative 6. This is not multiplication, it's adding. 0.2, 0.4, 0.6. Oh. Nick?
For problem 18, is it 2x squared plus x or 2x squared minus x?
Should be plus x, sorry. I was so wrapped up in it, I just lost sight of what I was doing. Emma Christ.
Number 13, I got negative 7 with the airplane.
And I don't know how you did that. How do you get a -7 with that whole mess? How did you get this 3 over to the other side? Well, 4 minus 3 is 1, is it not? So I don't know how you got 7, but I'm asking.
Never mind.
Okay. And there again, I've seen people, because there's a subtraction sign here, think that they need to add 3 to get rid of it, but no, that subtraction sign goes with the x. It doesn't go with the 3. There's no sign in front of the 3, so it's a positive, so you subtract it. Brandon,
Oh, no. It's yours.
you were asking about 13.2 again?
Oh, no. But for 19, why would you carry the -1?
Why would I do what?
You know how it's just a -2? How can you bring a -1?
I don't know which negative you're talking about. This?
No, yeah, no.
This?
Yeah.
Well, minus and a negative are the same thing. This is subtracting a -2 times a -2. I don't know what you mean, how can I bring it
Like-
over?
Because minus. Subtraction sign, why would you put it on?
Because it goes with it. If it's not necessarily a subtraction sign, think of it as being a negative sign, it doesn't matter, they're the same thing. You just know that you have 3 of them, 3 minus, 3 subtractions, 3 negatives, makes a negative. An odd number of negatives make a negative when you're multiplying. When you add them together, it doesn't matter, you don't know, because it depends on how big the numbers are. Nathaniel,
For number 14, I don't know how to get the answer because I never did these.
ever in your life? I think it goes back to the early days when you just didn't want to show your work. And I can't figure out how you can't get these, because it's, if you know how many quarts are in a gallon, and if you know how many minutes in an hour, Nathaniel, I don't know how you can't get it, because it's as simple as this, Nathaniel. You write what they tell you, 30 gallons per hour, and you just need to multiply by unit multipliers to convert gallons into quarts and hours into minutes. So which one, pick one, doesn't matter, which one you want to convert first. So if the G's up here, where does the G have to go over here? Below. And we're changing it into quarts. So you need to know how many quarts are in a gallon. How many? 4. So now my gallons have crossed off. I've literally just now changed the equation into 30 times 4 quarts per hour. So it's actually 120 quarts per hour. But I don't want it in hours, I want it in minutes. So if hours are here, where do they have to go over here? HR goes here and minutes go here. How many minutes in an hour? 60. Now my hours have crossed off. Now some people go wrong here. Please be aware, children, if it's on top, it goes together, and if it's on bottom, it goes together. You need to do 30 times 4 times 1. That's 120. You need to do 1 times 60. Did I do something wrong?
No.
That's 60. And 60 goes in 122 times. And it is 2 quarts per minute. Doesn't seem like the answer I read, but I guess it was, wasn't it? So, Nathaniel, I mean, there's the nice thing about unit multipliers is it takes all the thinking out of it. It's just boom, 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 boom. You don't have to think really about it, because sometimes people get confused when they're changing yards to feet, whether you multiply by 3 or divide by 3. This takes all that guesswork out of it. Jackson,
I don't understand your
that's funny. These people out early? Yes. Alright, Jackson, so tell me what you think you should do, sir.
2 square root of 6, I made it, square root of 3 times the square root of 2.
Okay, well, let's do that. I've got 2 times the square root of 3, right? From this, times what you just said, the square root of 3 times the square root of 2. That's the whole thing factored out, Jackson. When I'm doing square roots, what am I looking for? Pairs. There's a pair of 3, so that 2 square roots of 3 give me a
3.
regular 3. The 2 doesn't have a little pal, so it's going to stay. You have to take the normal numbers, remultiply them. And this square root of 2 just has to stay the square root of 2. You can't do anything more with it. Many a fine man hath gone down because of adding when he should have multiplied. Joyce?
Number 19, why would it's the negative 2 minus 4, why would you subtract 2 from there?
Well, they're both negative. You owe somebody 2, you owe them 4, you're gonna owe them 6. Why wouldn't you subtract 2? Well, you'd subtract 2 from negative 4 if you like. I don't care what order you do it in, but it's still, they're still, you're still in the hole and you're still in the hole. You're gonna get deeper in the hole. If you're asking me why isn't it adding,
Yeah, why did you?
because when you have 2 negative numbers, when you're combining 2 negative numbers, you add them together. If you owe me $10 and then you owe me another $15, you're gonna owe me $25. Okay? If it's 2 degrees below 0 and then the temperature drops another 4 degrees, it's now 6 degrees below 0. Okay, you have negative and you're making it more negative, is what's happening. Nathaniel?
How do you do 16?
Oh, we must have done 16 already. Now that one's a normal equation. How do you do a normal equation? How do you get rid of a minus 1/3? You add 1/3. If I add 1/3 to 2/3, I get 3/3. So if 2/3 x equals 3/3, well, I could simplify 3/3 and make it 1. And then the age-old question is, how do I get rid of a fraction in front of the letter? Just flip and multiply, reciprocal. Flip and multiply. And 3/2 times 1 is in fact just 3/2. Where are we at here? Pretty long, pretty much.
So you got number.
Problem number 8, 66 and 2/3, you just have to recognize that that is 2/3 as a fraction. We don't deal well with 1/3 and 2/3 as percents or as decimals. Have a Haynes?
The problem is, well, I don't understand how to figure it out after 2x equals 6.
Well, I don't, 2x equals 6 was an example, it was not really part of the problem.
So yeah, but alright, you did a right side thing.
If you have 2x equals 6, I was just trying to show whatever's in front of the x is what you divide by. So you divide by 2, you get 3 for an answer here. Same thing here, the a was in front of the x, so you divide by the a, so it just goes right under there. The problem is a doesn't go into any of them, so you just have to leave it like that. C minus b over there. Ooh,